You know what it is? It's some kind of a secret out of space. Nobody really knows what it is. But those few people who got to space, they just grab a little bit, put it in their pocket, and then something like this happens. What you see in front of you, wait, it's not there. Can you switch? Or do I need to switch?
Yeah, please.
If you are outside, as a day today, like, or yesterday, and you look up, what you see is the blue sky. The blue sky gives you a feeling of comfort. The sun is warm, it's nice. And in fact, if you lay on the beach, there's no thinking of that there could be any threat beyond this blue sky, because you normally don't see it. What I would like to do is to bring you up a little further away from this earth. Now this is a picture just out of an airplane. And if you look at this airplane, then you realize that the sky is not completely blue anymore if you look up high. But it is still comforting. You still don't see what is beyond. Now if you go in the US Space Shuttle Challenger, as I did in 1985, then you do see what is beyond. So let me start a little movie to remind those what this is all about. You were waiting about 2 hours inside the space shuttle, in my case with 7 colleagues, 5 Americans, 2 Germans and myself.
Minus 1 minute.
And then,
Sound suppression water system is now armed. Minus 55 seconds. The hydrogen burn igniters have been armed.
now you're looking at the last minute.
And these igniters will be fired
And at some point in time,
to eliminate any
the whole space shuttle takes over, full control over its own countdown. And that happens about 31 seconds before the takeoff.
Expect to have a go for auto sequence
You want auto sequence start.
Minus 31 seconds. And we have a go for auto sequence start.
I have to take this off. But it's going to be difficult because it's somehow behind.
We'll soon be arming the XRB ignition, hold down post and T0 on vertical orders. Minus 13 seconds.
Without that.
10, we'll go for main engine start.
Now the main engine starts, they will be checked whether the steering works. When it works okay, then the 2 side ropes go and the space shuttle goes up. It's quite impressive when you're inside. You're going to be pushed down 3 times your body weight because the shuttle accelerates that fast. Now listen to what the next call is going to be. We're throttling down, and the space shuttle is throttling down because the space shuttle should not go too early, too fast, because the air is too thin. And the speed at which you just heard we are throttling down is 1,000 kilometers per hour, which just happened in those few seconds which you looked at it. So the shuttle goes really, really, really fast, very fast. It takes 8 minutes, and it's all what it takes to just have this situation. The space shuttle has reached a speed of 28,000 kilometers per hour. That's the speed at which you, if you circle the Earth, are pushed to the outside because of the circling in the same amount as the gravitation pull from the Earth pulls you in. So you keep on falling around the Earth, you're weightless. You're, in my case, 300 kilometers above the Earth, and this is what you see. Now this picture looks very different from the picture which you had when you looked at the beach and you looked up, because you felt comfortable, you saw the blue sky, but now suddenly you realize that if you're down in the black, that you're somewhere where there's no oxygen, no air to breathe, where the temperature is 200 degrees minus, where there's no life, no history, and in fact, maybe nothing of value. And everything you know, everything which is really important to you, all the life, all the history, all the nature is right in front of you, it's the Earth. And now you realize that what you see there is that the Earth is protected from the dangers of space just by 20 kilometers of atmosphere. Something which looks very thin from the outside, while it looks so comforting when you look up. I was a week in space, 112 days of 112 orbits, which in fact are space days because the sun goes up and down just in 1.5 hours. And I asked myself, I said, well, when I'm back, I have to tell the story about my flight, and what is my conclusion? And basically, the conclusion is, it's not space that is unique, it's the Earth. In fact, I went through a mirror process which is the very same mirror process which already was there by the very first person in space, Yuri Gagarin. In fact, last 12th April, we celebrated 50 years. It was 50 years ago. When Yuri Gagarin went into space, it was after thousands of years of cultures which were fascinated by space, by the stars, by the planets, to the cosmos. And he went as the first person to the cosmos, called cosmonaut. And you know what? When he was there, the ground asked, Yuri, how do the stars look like? How do the planets look like? And what did he say? The Earth is beautiful. It's because the Earth is really the only thing which is really of importance when you're in space. And this is our Earth, seen from the moon. This is our Earth, and I hope you can understand that if you look at this way, you call this a spaceship. In fact, regularly I give speeches to young people, 12 years old. And I said, well, do you realize that you're on a spaceship? Now, what does that mean for you? How do you call the people who are on the spaceship? Exactly. So then I say, well, you're all astronauts. And of course, all these young people go, wow. And you just, okay, you're not 12 years old. I like to see that we are, as crew members on Spaceship Earth, but we don't do our homework very well. In fact, homework means that you just make sure it's not too warm, not too cold, there's enough energy, there's enough food, there's enough water. Just take care of it. Now, we made maybe quite of a serious mistake, and that was that in 1930 we started to drill oil and we started to burn it. Now, what is the mistake, or what's the problem? Oil has been made over tens of millions of years, collecting the greenhouse gas into algae. And these algae went to the bottom of the oceans, and that's the source of the oil. Oil is a concentrated greenhouse gas. So if we burn it in 100 years, then we ask for trouble. And in fact, that is where we are. We knew already around 1970 that we would get into trouble. That was the Club of Rome. But then we had no solutions. But now, and that's the beauty, I think we have solutions. But first I would like to show you a little bit of how big a problem we have been causing. And you can see that by looking into drilling into the ice and just recovering ice which was very, very old, snow which a long time ago fell on the Arctic or in the Greenland. And there you can see what the original greenhouse gas was at those years and what the temperature was. And in fact, this is probably very familiar with this picture because it's from Al Gore. Here you see from 0 to 500,000 years ago what, in fact, our greenhouse gas concentration was. And without going to specific numbers, but you see that 180 to 280 is kind of the scope, depending on whether you're in an ice age or not. In the last 50 years, we did that. We've jumped as much as the difference between an ice age and a non-ice age. Now, I don't want to put conclusions on that, but I think it's quite understandable that our climatic models, which have to make predictions in the future, are not working very well and that there are lots of discrepancies. Not because the scientists are stupid, no, because this jump is really high. Did we ever have this high concentration? Yes, about 60 million years ago. And then there was the climate, it was like a Jurassic Park. Violent, big thunders, lots of rain, and lots of green. The sea level was 70 meters higher, and there were reptiles. Now, this looks all pretty bad, but fortunately, now we have a solution. Fortunately, we can be optimistic this time. After the Industrial Revolution, we can go to something new, a new cultural step with a solution. And the solution is nuclear energy. Nuclear energy in the sense that nuclear energy, the beautiful formula of E is equals mc squared, Einstein's formula. Energy stands for E, m is mass, and you can multiply that with the speed of light twice, c squared. 300,000 kilometers, not per hour, but per second. You get huge numbers. And in fact, I offer you a nuclear power plant, which is already stable for 4 billion years, which is very constant, which is at a distance of 400 billion kilometers, safe, no political influence, no terroristic attacks, and at no cost, and it's for everybody, and that is the sun. The sun is the only viable, good nuclear power plant which we have. And what it is, it gives us enough. We don't have an energy problem. The sun gives us here in the Netherlands 100 times more energy than we need. On world scale, the factor is 8,000. In 1 hour, the sun shines enough energy on the earth as we use during the whole year. We do not have an energy problem. We start to understand how we can live differently. These houses in the north of Holland, they don't use external energy. They collect the heat in the summer, put it into the soil, use it to heat the house in the winter. They have photovoltaic enough to get their electricity. So you can be energy neutral. Yes, you can. I was at this house, and later on I'll tell you why I sold it. But it was full of solar, and I know exactly how much solar you get in the Netherlands. And it doesn't look that weird. These blue dots, 4 of them, would be enough solar to cover the whole energy needs of the Netherlands. Or another example, we have a big dike, and 6 meters slope solar will give you the same amount of energy as all the cars need on that dike, which is 18,000 cars a day. 32 kilometers of energy neutral highway. At the cost of what? You know what? Is about half of the cost of a sound barrier. Or suppose you buy yourself a real fast electric car like a Tesla, and you drive 15,000 kilometers an hour. Then in the Netherlands, per year, then in the Netherlands you need, sorry, I'm just used to very high speeds. But you need only 30 square meters of solar, and you know what the cost is? About 10 to 15,000 euros. That's 10% of the cost of that car. It's an expensive car, but 10% more, and you have bought yourself all the energy you ever need for that car. Solar is super. We have plans in Europe to just connect to various countries to stabilize our outputs. You can do all kinds of things. And this maybe is one of the most drastic graphs which I know at the moment as far as solar is concerned. This is the price of solar. At the moment, solar in the Netherlands without subsidy is already cheaper than what you get out of your socket for a private person. Next year, it will probably be like 80% lower. I mean, we're going to see solar everywhere. We're going to see solar in a booming state like we did with the iPhone. Everybody can buy solar. And you know the source, solar, where does it come from? Photovoltaic. What is it? It's sand. We have enough. What's going to happen if we double? Doubling is a funny thing because it's difficult to assess in advance how far you go because it goes so fast at the end. Today we have 3,000 of energy in solar, and in 2 years it will be used about 1%. Still not very significant. But then it goes to 2%, to 5%, to 10%, and before you realize, within 10 years, we'll have more energy from solar than we have today with all the power plants. That will be really a change. I'm very optimistic because of this, but also because of the young people which I work with. In fact, each 2 years, we go to Australia with our team of students, and I'm a coach and an advisor, and we race there with these vehicles, purely on solar. And just to give you an impression, a very short movie on what's happening there. You're driving at a speed of typically 100, sometimes 110 kilometers an hour, purely on solar. Here you have the last control stop. This is at 2,700 kilometers. The total track is 3,000 kilometers. We are 10 seconds behind Michigan State University, and the tension is enormous. Because although we already driven over 2,800 kilometers, they're still fighting for the last second. You see here one of the overtakings. And this, what we call cat and mouse play, was going on the whole day. Here you see that I'm making some of the lives a little difficult. And this is the last overtake where we just made it to our second place. Speeding up here to about 120 kilometers an hour. And can you imagine, this is just on the sun. This is just straight sunlight converted into energy, which is used to move that car. We have more of those projects. One of the projects is here in the Netherlands, in Friesland, where little solo boats are going to this race. I was invited, you know, by the way. But these boats nowadays, they go so fast. They go 20 kilometers per hour. I give you a small impression. To a father with his 8-year son when some of those boats passed by at high speed with no sound, no waves. And he says, Daddy, when I'm old, I want to have a speedboat like that. It's the new age which is coming. It is the jump towards a new time. Look at this guitarist. It's a complete Santen. But the energy is made by heights. Why not? You can do these things. Okay, a little bit. I want to do it very slowly. Aloft, the kite is pulling a rope, and the rope drives a generator, and the generator gives the energy to the rock monster. And you know what the nice thing about that is? If you have a little kid and is looking at a kite rather than at a chimney, when it's looking at a kite which makes energy, you see the brain going, the imagination going, the fascination going. It is just a much nicer way of getting your energy. Another example. This is my next house. I showed you the other house, the big house. We sold it to get enough money to do this development. It's a big project. It's an 84-foot sailing ship, and it's our new apartment. But what's special about it, apart from the fact that we can sail it just the two of us, my wife and myself, is that there are two kind of water mills underneath the ship, that while sailing it generates this energy. And it stores the energy in batteries. We have 10,000 kilograms of batteries, which is the ballast. And then we can live about 3 weeks on that battery. Now suppose you lay in the harbor 2 weeks down and then you've used maybe a little more energy, and my wife says, well, we're a little low on energy. Oh, I have to sail. Because then we have to go out to collect the energy. So we go out to the sea and we come back full with energy. Isn't that really beautiful? In other words, what I'm saying is that sustainable development and the innovation which corresponds to that is leading you to things which are just better. It is not just a replacement of the way we were doing things. No, it is a jump in culture, leading to something which is more advanced, more pleasant, more exciting. Well, one of the more exciting things is this one here. This is Superbus, which is a new type of public transportation, which I started thinking of in 2004, finally got money to realize it. It's a very high-speed bus. 250 kilometers an hour, using the same amount of energy as a normal bus with 100. Of course, it's much lower, but it has the same length and the width. And here it is. It has many doors, because if you want to get in and out, you don't want to disturb the others. It has the luxury of a private car, or even beyond, of a limousine. It's a competitor to the private car. Here you see the rear. In fact, I was in Germany at a speech for Harting, which is an important company of all computer connectors, and the top 100 people were there, outside big BMWs and big Audis and big Mercedeses. Imagine imagine you buy yourself a new Audi 8, you drive on the German Autobahn 200 kilometers an hour, really enjoying all the luxury and the advancement in technology which you have around you, and then something passes which looks like this from the rear, and it's called public transport. I was very lucky to have this woman go to me and work for me. This is Antonia Terzi. She comes out of Formula 1 world, and she did the design of the Superbus. The first ride I could proudly do myself. Just have a little.
The rocket engines ignited. The shuttle heads up, accelerates, and it lasts only 8 minutes, and then you are expected, and float around the Earth. My mission is to make clear what the Earth means.
The first view of the Earth is a shock because of its inhuman perspective.
I've seen it.
We're all astronauts.
Of our spaceship, Earth.
It is our responsibility to maintain spaceship Earth in good quality.
Reflect the future.
There's only one Earth. And there's no spare.
And there's no spare.
Yeah, beautiful pictures. We had Superbus in Dubai last week. I came this morning, and it's a big success. I'm rounding off. Why are we doing all this? Well, of course, for your own excitement, but really for these people. These are the stakeholders of the future, and sustainable development means that we take care of the future, that they have at least as good a future as we have, or even better. That's what we need to work for. But it's going to happen, that's what I said. I mean, I'm optimistic it's going to happen, and I have a very strong drive, which started with the space perspective, to really fight for it, to make absolutely sure we go in the proper direction. That proper direction, I think, is going to be a new cultural step to a nicer culture. A culture where lifestyles don't have this little black ash of, oh, I pollute, or I have some big problems with resources which are just not endless. I have problems with wars. I mean, all these things which we have really as a problem today, maybe we could get rid of. This new culture, I thought about a logo for that new culture. A logo which you see is built up out of a flower, sun, the water, and the earth, called happy energy. I'm walking around with happy energy because if you work on this way, which I do, you become happy. You become very energetic. It is just the right thing to do. You feel that in all the senses of your body. I wish you can sense the same happy energy. A happy energy which is like an icon, like a peace icon, a recycling icon, which you can then see everywhere. Like this, merchandising. Isn't it beautiful to have this radiated out of this pleasure which you see of the new culture which is going to come? Everywhere where I am, I'm expressing this happy energy. I'm expressing this optimism. And I really wish that you feel what I feel when I talk about it. I would like you to give your applause now, and then I have a surprise. Just to show you that I'm really convinced that this is the right track to go. On the 28th of March, I had my birthday. I became 65. And my birthday present was this. Thank you so much, and I really was very happy to talk to you. Remember, you're all astronauts in space at Earth.